Hello guys, this is Raj. So yesterday there was a lot of work and meetings, so I couldn't study much. So today we have to today we will do the catch up with the rest of the stuff, and we have a lot to read. The plan for today is to read pharmacology, at least the one full presentation, and then go to pathomorphology. Yup, let me check the stream and then we can go about it. Okay. So, I guess everything is fine. Yup. And one more time. So, let's recollect what we studied yesterday. What did we went through? Okay. So this is where it started. General pharmacology, non-cellular, cellular, molecular, pharmacodynamic, pharmacokinetic. Okay. Insensibility and hypersensitivity of drugs. Antibacterial agents, antifungal, anti-cancerous, antiparasitic, and inside parasitic it's protozoal, nematodal, cestodal, trematodal, and then ectoparasiticides, okay. And then there are some examples. I know, like last time I said about the forming mnemonics, I did not get time to do that. Maybe I'll do it after today, after today's video, by the way. So tetrahydropyrimidines, imidazoles, tetrahydropyrimidines. Okay, what is pharmacology? Is the science of the properties of chemicals and their effects on living organisms. Science of properties of drugs and their effects. Pharmacology is the study of therapeutic and prophylactic. So veterinary pharmacology, medical pharmacology, there are two divisions up there. Let me check once. So what is a drug? Drug include natural or synthetic chemical agent. Okay. Treatment, prevention, and control of physiological process. Okay, this is quite important. Pharmacodynamics is biochemical and physiological effects of drugs and their modes. Biochemical and physiological effects of drugs and their modes. Okay. The relationship between drug and concentration. Drug concentration and effect. Okay. And then pharmacokinetics is defined as the mathematical description of temporal changes in concentration of drugs and their metabolites within the body. Okay, mathematically or quantifiable change in the concentration of drugs. Okay, pharmacokinetics is quantifiable, numerical changes in the drug concentration. Okay. Here, pharmacodynamics, the biochemical and physiological effects of drugs, and then the relationship between the drug concentration and their effect, dosage. We can say dosage, okay? Based on the dose, how much is the effect? Yeah, okay. Pharmacokinetics is the study of mm, okay, in this case, what are all the components within pharmacokinetics, like liberation, absorption, distribution, metabolism, and excretion? Okay, liberation, absorption, distribution, metabolism, and excretion. It is the fate of the drug in the body. Okay. For what does the drug do? Okay, drug dosage, and what does the drug do? Here is like how it's performing with inside the body, how it acts, and therapeutics. Branches of pharmacology: neuro, chrono. Chrono means something to do with time. Here, biological timing and endogenous periodicities. Clinical pharmacology, co-pharmacology, geriatric pharmacology, pediatric. Clinical. Okay, geriatric is something we also browsed yesterday. It means old people. Pediatric is diet and food intake, and then gastrointestinal, cardiovascular, respiratory. General pharmacology or specific pharmacology. Specific, as the name says, it's specific to certain organ or a system. In this autonomic nervous system, central nervous system, cardiovascular system, different types of systems, and then anti-inflammatory properties as well. Okay, how can we present a drug group? The name, the name, the international name. I'm so sorry. Name, international names, pharmacological effects, mechanism of action, pharmacokinetics, contraindications, adverse effects, and drug interactions, and then instructions of use. And these are the sections, these are the branches. Okay. So veterinary drugs are used to cure or prevent diseases in animals, including companion animals, farm animals, and what else? Which are used for food production, cattle. The use of veterinary drugs in farm animals may result in the rescues. Okay, this one also is quite important. Like these drugs can end up in their products that they produce. Like it can be meat, milk, or eggs. Okay, so this is all the new stuff for now. Let's go. Definition of MRL: maximum residue limit. Okay, maximum residue limit. Okay, what they say is if you sample a tissue or sample an egg or I mean, in this case, contents of the egg, milk, or meat. So any of these three, if you just sample it and then you try, or you just when you sample it and then check for the amount of drugs that they possess in micrograms, I guess. I do not know the units till now, but yeah. So how much quantity is present? So there is a maximum allowable limit. If it crosses certain specific threshold, then probably it's very dangerous for humans to consume, I guess, or for any sorts of consumption. Yeah. Drug action. Initial consequence of drug receptor combination. For example, atropine is an antagonist. M receptor. So initial consequences of drug receptor combination. Okay, so how does a drug work? So it's a chemical molecular compound. It binds with a cell receptors, I guess, through a, as I said, this receptors are made of protein. So these protein binds with the drug molecules or captures the drug molecules and holds in place. So in this case, they are giving an example of atropine is an antagonist of M receptor. This is how drug action starts. Okay, M receptor. The entire thing can be said as drug receptor combination. Drug affect biochemical and physiological changes that occur as a consequence of drug action. For example, atropine antagonist, tachycardia. Okay, and decrease. Okay, what are the effects that it causes in the body when you take the drug? It causes tachycardia. What is tachycardia? Like increase in the heart rate, right? And decrease in the motility of GI tract and urinary tract. So GI tract always has to move inside the gut. So that's how it pushes the food down to the rectum, and also that's how it absorbs the nutrients. And then so that is a very important characteristics of GI tract. So that is reduced. Okay, and inhibits salivation, lacrimation, bronchial secretion, and secretion of other glands. Wow, so it does a lot of things. So first is atropine is an antagonist for an M receptor. So atropine is the drug that combines with the M receptor. That's a drug action. Drug effect is basically what it does because of the tachycardia, reduces motility and other things. Type of mechanism of drug action. Non-cellular mechanisms of drug action, cellular mechanisms of drug action. Okay, this one we kind of read before, cellular and non-cellular, and then molecular was the third one. Okay. Let's see outside the cell first. So drugs that act outside. Okay, osmosis and direct chemical interaction. Okay, directly reacts with the chemicals with the in the fluid, and then osmosis. Okay. Let me check the stream once. Nice. So okay, so mechanism, it can act on the cell membrane or it can act inside the cell. So inside the cell, those are the drugs that are steroidal, that can pass through the phospholipid bilayer and act. The ones on the cell membrane are the ones that act on the cell receptors. So see, specific receptors. Inhibition of membrane bound enzymes. Okay. So what it can do, it can bind with the receptors on the cell surface, and then it can inhibit the ion flow, it can inhibit the enzyme bound inhibition of membrane bound enzymes. Okay, so what are the enzymes that are present on the cell surface can be inhibited? Selective passage of ions, and then physiochemical interaction. And then how can it affect inside the cell? Once again, the enzyme inhibition inside the cell, and then transport processes, inhibiting the transport, incorporation of into large molecules like vacuoles, I guess, and alternative metabolic processes unique to microorganisms. Basically affecting the metabolisms of the cell and how the cell normally functions. And then I think this is cellular. This is drugs outside the cell. Okay. Non-cellular mechanism. Okay, let's see. Non-cellular, whether drug may occur extracellularly and involve non-cellular constitutions. I guess this one. Let's see. Physical effects. Protective, absorbent, lubricant properties of drugs. Protective, absorbent, lubricant properties of drugs applied to the skin. Yeah. So non-cellular. Okay, I understand. All the mosquito repellent and stuff, I guess. Sunscreen. Maybe not sunscreen, but yeah. Okay. Non-cellular ones are the ones that can also be used as an antacid in the stomach for acidity, I guess. So gastric hydrochloric acid is neutralized by antacids. Okay. So some of the examples are magnesium, aluminum hydroxide, and calcium carbonate. Okay. So this is how non-cellular stuff happens. And then some more non-cellular thing. Physiochemical drugs may alter the biophysical properties of specific fluids, surfactant, detergents, anti-foaming agents. Okay. So they are purely chemicals that disrupt the normal functioning of the body. That doesn't involve a cell specifically here. So here, for example, they are saying surfactants, detergents, anti-foaming agents. Suppose if someone consumes it, alters the biophysical properties of specific fluid. Modification of, just a moment. Modification of the composition of body fluids. Okay. Osmotic influence. Yeah, this is one of the things, right? Across cellular membranes. Yeah. Direct chemical interaction, and then this physical effects, chemical effects. Okay. And osmosis influence, and then physiochemical. Okay. Physical effects, chemical effects, and physiochemical mechanisms. Okay, and then modification of. Okay. Now cellular mechanisms. Let's highlight this. So it can be either surface or inside the cell. So the first one is what? Physiochemical. physiochemical and biophysical mechanisms. Okay, so what are they saying? Let's start with the example that's much more fun and somewhat practical. So, if you take inhaling anesthetic, what it does is it affects the lipid matrix that are present in the cell membrane. Polymyxins are cationic surface active reagents. Cationic surface active reagents that disturb the phospholipids of sensitive bacteria. Okay, so polymyxins can be used to kill bacteria that are made of phospholipids that are sensitive to the polymyxins basically. Okay. Okay, sometimes they affect the cell structure and function. Obviously, the structure is something interesting. I only knew the viral infections kind of affect the structure of the cell. Okay, various drugs may influence the structure or the function of the specific functional components of cell membrane. For example, local anesthetic bind to sodium channels in excitable membranes, prevent depolarization. Okay. So they block the nerve impulses in a way that the muscles are either in excited state or in a relaxed state. When you take some local anesthetics, what they do is they bind with sodium channels. Okay. Where prevent depolarization here means the muscles will not get excited in a way. So it's more like um, in a paralyzed state or sleeping state, I guess. So calcium channel blockers inhibit the entry of calcium into cells. That's also very important for motion, to for the movement of the muscle. That is important. Okay, that's happening. And then, oh, now I understand the structure. So the muscles won't stretch. Yeah, it can be botulism or tetanus, where tetanus is like you is full stiff hands, and then botulism where you are like spastic paralysis, so you cannot move your body in a way. So yeah, and function is like insulin helps in the transportation of glucose into cells. Okay, in this case liver cells, right? Okay, what are all those things that are there? Receptor type G protein. Okay, types of receptor and how they interact with the drugs. That's the next topic. And okay, So what I think I should do now is go through it a little bit more faster so that I have gained some confidence that I'm doing progress, and then I'll come back and revisit it again. Okay, so let's go. So cellular mechanisms of drug action. Enzyme inhibition. Certain drugs exert their effects by inhibiting the activity of specific. Okay. Competitive, non-competitive, reversible, irreversible. Yep, that's a very important thing. There is a cells receptor, and then it's waiting for some kind of a molecular ligand or any other chemical compound that can act as a combination for it, like a lock and key mechanism, like a key for that lock to combine. So what these kind of enzyme inhibitors do is basically they come and then they block either the entry, or they connect in different locations of the cell receptors, and they competitively block or non-competitively, reversibly, irreversibly they block those receptors. Okay, the irreversible ones are also known as suicide receptors. So yeah, enalapril. Enalapril is an inhibitor of angiostensin converting enzyme, decrease blood pressure. Enalapril, angiostensin converting enzyme, decrease blood pressure. Okay. Okay, so when I take enalapril, enalapril. Okay, that's very important to pronounce it right so that it sticks in my mind in the right way. Otherwise, I'll be always saying the wrong names. So it's not good to be a doctor, potential future doctor, and saying stuff wrongly. Enalapril. Okay. Angiotensin converting enzyme. So there's an angiotensin converting enzyme that's present in the cell surface, I guess. So this drug, what it does is it basically inhibits that enzymes, and then it decreases the blood pressure. Okay, let me check the stream if everything is good. Okay, 27 minutes. Wow. So pymobendan is a inhibitor of phosphodiesterase type 3 isoenzyme. Okay, bendan. Therefore, it does what? Decreases ionotropic and vasodilator effects. Okay, it dilates the blood vessels, and then positively ionotropic. They allow the flow of ions. So in this case, enalapril and pymobendan both are acting as inhibitors. One is inhibiting angiostensin converting enzyme, another one is inhibiting phosphodiesterase type 3. Pymobendan, phosphodiesterase, enalapril, angiotensin converting enzymes. Okay. One causes vasodilation, pymobendan. One causes decreased blood pressure. Okay, they are showing how it works. Okay. Inhibitor of enzyme activity. Angiostensin converting enzyme inhibitors. What does it do? It decreases blood pressure. How is that doing? Let's see. Cardiorenal effects of ACE inhibitors. Okay. ACE is angiostensin converting enzyme is called ACE. So vasodilation, arterial and venous. Okay, it also causes vasodilation. Okay, reduce arterial and venous pressure, blood pressures. Okay, reduce ventricular afterload and preload. Okay, decrease blood volume. Okay, when the blood pressure falls, obviously the volume also falls because not enough blood volume is pumped. So makes sense. And depress sympathetic activity. Let's also look at the diagram once again to get make better sense. Kidneys release renin. Renin is an enzyme released by kidney. Renal, so you can remember that way. Renin. It causes angiostensin converting enzyme. Angiostensin to angiostensin 1. Okay, still not the angiostensin converting enzyme is not involved yet. Angiostensinogen, it becomes angiostensin 1. And then now AS inhibitors block the action of okay, this is where the angiostensin converting enzyme is there to convert to angiostensin 2, which is blocked. That's the reason blood pressure, venous pressure, all those things drops, and thereby volume of the blood drops, and then it prevents the vascular hypertrophy, inhibit cardiac and vascular hypertrophy. Hypertrophy is basically enlargement of whatever, in this case heart or blood vessels, I guess. Yeah. Okay. Wow, a lot of technical stuff. Acetazolamide is an inhibitor of carbonic anhydride diuresis. What is diuresis? Let's ask ChatGPT. Increased production of urine by kidneys resulting in urination. This process occurs when kidney filter. Okay. Carbonic anhydrase. Okay, that prevents diuresis. Okay. Increased production of urine. That's what we are trying to prevent. That means basically excess water loss, electrolyte loss, right? So meloxicam is an inhibitor of COX-2, anti-inflammatory. So okay, analgesic, antipyretic. Okay, these are new terms. Analgesic, I guess something to do with anesthesia and stuff. Analgesic and antipyretic. In a table, I always ask in table so that it's easier to digest the information, otherwise you see this, if you are gonna see this, rather you could see this. Is, I guess, in my perspective, this is so much easier to consume the information. Analgesics that relieve pain and discomfort. They work by blocking pain signals. Okay, meloxicam does blocks the COX-2, COX-2. So anti-inflammatory, analgesic, okay, so blocking pain. Ibuprofen. Common names are aspirin, naproxen, ibuprofen. Ibuprofen, aspirin. Headache, muscle ache, pain, all those things. Possible side effects: stomach irritation, bleeding, allergic reactions. Okay, anti-inflammatory. Here we go. This also is there. Antipyretic. Okay. Oh, antipyretic. Pyretic, something to do with temperature, I thought, or heat. So it reduces fever. Act on hypothalamus, reduce the production of okay, reducing prostaglandins in the head, hypothalamus. Okay. Once again, ibuprofen, acetaminophen, naproxen. Primary effects is reduce fever. So fever, body pain. Okay. So meloxicam is an important one. Acetazolamide is diuresis. Wow, this is interesting. Actually, all these things is very interesting. Let's do this. Fluoroquinolones are inhibitors of bacterial DNA. Gyrase. So it kills the bacteria. Fluoroquinolones, yeah, bacterial. Yeah, in microbiology we read like a lot of times. This is a drug used to kill a lot of bacteria. And then let's do one more one. Bacteriocidal bacteriostatic effect. It does not let it multiply, I think. Inhibitor bacterial peptidyl transferase. Okay. Tiampenicol. Bacterial peptidyl transferase. Bacteriostatic effect. Okay. Bacteriostatic effect. Let me confirm that. Meanwhile, valproic acid. So inhibitor of gamma aminobutyric acid. GABA. Oh, okay. It inhibits GABA. So convulsant effect. So it doesn't let you go paralytic. Anticonvulsant. So what is bacteriostatic effect? Bacteriostatic effect refers to the ability of certain substances such as antibiotics and other antimicrobial agents to inhibit the growth and reproduction of bacteria. Growth and reproduction. Yup. Without necessarily killing them. Okay. So what they do is they inhibit the bacterial growth and without killing them, the body's immune system can work to eliminate them. Thereby producing immunity as well, right? That's nice. Anticonvulsant effect refers to the ability of certain medical substances to reduce the occurrence and severity of epileptic seizures. Yeah. Okay. Okay. Anticonvulsant. Valproic acid. Okay. Got it. GABA. Inhibitor of GABA. Meloxicam is COX-2 anti-inflammatory, analgesic, pain reliever, antipyretic, fever reduction, and diuresis is acetazolamide. Tiampenicol. Okay, let me go for a quick break. Maybe end the stream and continue it again. Okay, guys. Thank you so much for being with me. It's really hard to put yourself to study, when it's holiday. Yeah. Thank you.